So the first part is I want to show you right here is what is an inverse. Okay, so first things first, what do we even mean by inverse? What does that even mean? So I'm going to give you a very simple, I call them silly examples, okay? Because if you understand basic silly, then you'll understand harder stuff, okay? So make us a small graph like this, just a little grid. This one's not big, just small, okay? And cut it perfectly diagonal, like that. I'm going to give you an explanation of what all inverse functions look like, okay? So this little diagonal is the parent linear function. This is the linear function you've been doing since 8th grade, 9th grade. Okay, this is the original before you move it or anything, okay? Now, again, this is a silly example just to help you get the point across, okay? If I draw a heart, okay, and I call that f of x, think of if I could fold this TV on this crease and this heart was wet ink, how it would leave the imprint on the other side. See if you can visualize what would that look like. Okay, so if I were to fold it right there and then this would fold onto this, how would it look? This is what it would look like, give or take, roughly, right? If you fold it right there. Okay, well, that heart didn't come out as good because it's upside down. But this right here, guys, it's an inverse. Okay, it's not a function because it's a heart, but that's what it does. It folds, they fold over this line, okay? And that's what we do with parabolas. That's what we do with cube root functions. With all functions, that's how we find the inverse. We fold them like that, okay? So now, let's get to this part. Let me go down here. Now here's the more important part. Part 2. Okay, we're going to develop the inverse sine function. Okay, we're going to make the inverse sine function. So what I want you guys to do, this time a little bit bigger, okay, not a small one. Draw a little bit bigger grid. And it's going to be really small. We're just going to go from 1 to -1. And then spread these two out. Okay, spread them out. So this would be pi over 2 to pi, negative pi over 2 to negative pi. Okay. We're not going to write all the other in between. And I'm going to take a segment of the sine function, okay? So I'm not going to show you again on the unit circle because we've done that already several times, but you guys know where these points come from, right? It's the y values on the unit circle. So we have one here, at 0 it's 0, at pi over 2 it's 1, and at pi it's 0. So if I connect these dots, that's a sine function. Okay, that's the segment of the sine function from negative pi to pi. Now, what I just did, relating it to what we were doing earlier, I just drew the heart, the first heart. This is the original one, okay? Now we're going to make the inverse. So how did we make the inverse? We folded it, right, across. So again, we draw this diagonal line, which we call the parent linear function. This one's harder to visualize, which is why I showed you the heart, because the heart's really easy to visualize, right? But it's the same exact concept, okay, guys? Pretend the sine function is wet ink, fold it, and see if you can picture what that would look like. Now, you got to do one half at a time because there's two halves. So just picture this half. If I were to fold it, what would it look like, okay? And that's what I'm about to draw. Okay, so this part would look like this. Just like the heart. Okay. This part, if I were to fold it, it would look like that. Okay. Now, if you have a hard time visualizing that, that's okay. I can show you on a piece of paper and actually fold it for you, but if not, just take my word for it, okay? Okay, so over here, go to the side, and let's draw another grid, okay? And I'm just gonna draw that red one that I just drew, okay? So it would look like this, because right here it's getting kind of messy, right? But just isolate this one. That's what it would look like. That right there, ladies and gentlemen, is almost your inverse sine function. Almost, not quite. I have to do something to it. We have to fix it a little bit. So this -1 right here, okay, it's not a -1. That's how we, that's the symbol for inverse. Okay, so that's what we mean by -1. Okay, now what happened here is we switched, right? We flipped it, right? And something that's really important that's happening here is the x-axis is becoming the y-axis, and the y-axis is becoming the x-axis. So let's put some numbers over here. So now, instead of going from -1 to 1 on the y, we're going from -1, let me switch colors here, to +1 on the x, because we switch. The y of the original one becomes the x of this one. The x of this one becomes the y of this one. We're switching. So instead of going now from here to here on the x, that becomes the y. So this is -pi to pi. Pi over 2, -pi over 2. Inverse functions, this is really important. Inverse functions, the x and the y's switch. Okay, they switch. Okay, I told you it's kind of heavy, okay, here in the beginning, but are y'all with me? Is it making sense, following where everything's coming from? Good. Now, let's go back to 8th grade. Anybody here remembers how can we tell if something is a function or not a function? Anybody remember? You guys remember the vertical line test? Kind of a little bit?
If it doesn't have the same x value twice.
If it does, the x's can't repeat, is what she's saying. So right here, when you did this back in 8th grade, 9th grade, your teachers would have you scroll the pencil across it, or they would have you draw a vertical line like this. And if it touched more than twice, which is what she just said, it's not a function. It doesn't work, okay? So this right here is not a function. It can only touch once. For example, let me go here to the sine function. This is the sine function, right? If I put my pencil here, how many times do I touch it? One. That's a function. This is not a function because it touches twice. Does that make sense what I'm saying? Okay, and that kind of doesn't make sense as when I was a student. What do we mean by not a function? I always explain it like this. Think of a Coke machine. You put in $1, you want a Coke, and you push Coke, and you get 2 Sprites. I mean, that'd be good, right? You're getting 2 for 1, but you're not getting what you're supposed to. It's spitting out something you don't want. So if I fix this, okay, now I'm getting here the important stuff, so stay with me. If I fix this a little bit, what color can we use? So if I cut it from here, if I erase this part, and I cut it from here, I erase that part. Let me ask you this now. Is that a function now? Yes. Okay, so let me draw it, this part. Let me draw yellow. Maybe yellow is better. So is this yellow part a function?
Yes.
That right there is the official inverse sine function. I can't do all of it because it's not a function, but if I cut it, which is called a one-to-one function, now it is a function. So this right here, guys, it's this one. We good? Making sense? Trying to make you understand why, okay? So what do we mean by cut? Is we restrict the domain and the range instead of cut, okay? So the domain of this, so this is important, okay? So this is for the inverse sine function. What's our domain? We're going from -1 to 1, right? For that little yellow squiggly that I drew, right? And this is the most important part, okay? I think. What is the range for the inverse sine function?
Pi, no, wait. Pi over 2.
Yeah, pi over 2. Negative pi over 2. 2. Where did I make the cuts, right? Negative pi over 2. 2. Pi over 2. Okay? Those cuts is what we call restricting the domain. Okay, and this is probably the most important part of today's notes is that you understand this. For inverse sine function, we have to restrict the range and the domain so that it works. Okay, so we can't do all of it. We have to cut it so that it works. Does that make sense what I'm saying? Okay, that's the heavy part. Okay, any questions right now, guys, that you have?
Do they always like reflect off each other?
They always do. And then the next days we'll do cosine and you'll see that they do. Yeah. Okay, I'm going to separate the video.